Hey scholars, it's Miss Marnon. So today we're going to start talking about how to find percents of numbers. So last week we worked on conversions between decimals and percents, and then we kind of started to figure out how to find percents, like if we were given a story about if you got 8 out of 10 points on a test, what the percent is. So today we're going to try to figure out what number a percent is of a whole. So if I tell you there's a total of this much and I want 8% of it, you can figure out what it is. So let's look at this review question first. In a gym class, 75 students took a fitness test. 5 students could do more than 10 pull-ups. What percent of students could do more than 10 pull-ups? So this one is a review, so you're finding what the percent is, so you have to figure out what that fraction is and then what that percent is. So you can pause the video and try this now. Okay, so if you were to write this as a fraction, we have 5 students who could do 10 pull-ups or more than 10 out of 75 total students in the class. I'm going to get out my Desmos Calculator. So luckily for me, I have it bookmarked right here. So if you don't have it bookmarked yet in Google Chrome, just click the star and add it to your bookmarks bar. So I'm going to write this as a fraction. We need 5 over 75. And we get this 0.06 repeating. So let's just go write this decimal, or at least a couple digits of this decimal down. So we got 0.0666, and it keeps going on and on and on. If you're using that yellow calculator, you can hit the second percent button and it will tell you what it is as a percent. Because we don't have the yellow calculators online right here, what we need to do is we actually need to just multiply this number by 100 or move that decimal over 2 places. So now we actually have 6.6 repeating on and on. So we can put the line here to show that it repeats percent. So it's 6.6 repeating, or 6 2/3%. So now we have our preview question. So of the 75 students in the gym class, 16% of the students received the highest grade on the test. How many students received the highest grade? So this you're just going to try. See if you can figure it out. Think about if I told you a fraction of the students, what you would do with this problem. Okay, so hopefully you've tried this. If you remember, when we had a fraction, we would actually end up multiplying. So we have the whole, this is our whole, and we have a part of it. We were saying we want 16% of this 100% total. So when we have the whole, we just need to multiply. So we can take our 75 students and we can multiply it by 16%. If you have the yellow calculator, you can type this in exactly how you see it, that TI-34 calculator. You can type in 75 times 16%. If you don't have that calculator, you need to change this percent to a decimal. So 16% as a decimal, we have to move this decimal over twice this way. So we're going to move it to the left twice, and it's going to actually be the decimal 0.16. So we have our decimal, we can type 75 times 0.16 on our calculator. We should be able to type that on any calculator. So let's try that out. So 75 times 0.16, and I got 12. But here's something else I want to show you. So if you are using this Desmos calculator and you want a percent of a number, watch what we can type instead. I can type in 16% and it will say percent of. So now I can just type in the 75 and it will still give me the 12. So we can always convert to a decimal, and this way will always work. Or we can use on this Desmos calculator this percent of button. So we put in the number we want for our percent, and then it says percent of. We put that whole number that we want right there. So this is actually going to be very helpful when you're doing your practices on Canvas and on Delta Math. So let's look at our notes here. I'm going to give myself a little more room because I write a little big. A classroom has 40 students in it. So part A, 60% of the students are wearing t-shirts, how many are wearing t-shirts? So again, we have the total amount of students or the whole amount of students. We want to find the part of students. So we just want to know what part of the students in this class. So we're looking for a number smaller than 40. If you wanted to, we could draw a tape diagram. This whole diagram would represent 100%, and we know that's 40. So if we wanted to, we could break this up. If we want 60%, we need to break this up into equal pieces. 60 is kind of over past half. It's not going to be equal pieces, but we can break this up into pieces of 20. So there's 20, 40, 60, 80, and 100. So now they're equal pieces of 20% each. So if you wanted to use some kind of tape diagram or double number line, this 40 students, you can split in these 5 boxes, or 40 divided by 5, and we know there's 8 in each box. And I only want 60%, so that's up to the 60% line. So that's 3 of those 8s. 8 times 3, or 8 plus 8 plus 8, I get 24 students wearing t-shirts. Now you don't have to do a diagram, but that's just one way that you could draw a diagram for a percent problem, and I wanted to make sure I showed that to you. If you remember that if we have the whole and the percent, we just need to multiply, you can do that too. So if you just wanted to do 40 times 60%, so you can type that on a TI-34 just like that, or you can write it as the decimal. It would have to be 40 times 0.60, or if you want 60% of 40, we can type it on Desmos as 60% of 40, and it will tell us that it is 24. So any of these ways work, as long as we're showing our work and how we got to our answer. So let's look at part B. I'm going to give myself more room. Instead of a tape diagram, I'm going to try doing a double number line for you guys. So 15% of the students are wearing Crocs. So we're still talking about these 40 students total. How many students are wearing Crocs? So this tape diagram, it kind of doesn't work. We got 2 numbers. So something a lot of people like to do are double number lines. So it's just exactly that, what it sounds like, 2 number lines. So we can have students on top and percent for the bottom one. So our whole or our total is always going to be 100%. In this case, we know what it is. We know that 100% is 40 students. We know that we want 15%, and we need to figure out how many students that is. So using a diagram like this, there's a couple ways you can do it. It's essentially going to be like a tape diagram where you want to split it up into a couple different parts. If I wanted to split this up, 100 divided by 15 doesn't split evenly, but I know that 15 can be divided by 5 and 100 can be divided by 5. So if you wanted to, you could split this up 5, 10, 15, 20, 25, and so on. That would give us 20 boxes. So you'd have to do 100 divided by 20, and that would give us that 5%. And by 100 divided by 20, I meant 40 divided by 20. So 40, split it up into the 20 boxes that we would need for all of those 5, 10, 15, 20, 25, and so on percents. This is going to be 2. So every 5% is going to be 2. So that means 10% would be 4 and 15% would be 6. So this one doesn't work so well, 15%, but we can still reason and kind of use some flowing how we would with tape diagrams with that. This works better more for when we have something that's like an even break or split of 100, like 10% or 25% or 50%. But we also might remember from the last one that if we have the whole and the percent, we can multiply them to get our answer. So we can really just do 15% times our total of 40 students. Or if we're not using the calculator that has the percent button on it, the TI-34, we just need to change it to a decimal. So it's 0.15 times 40. And we can type that on our calculator. So I can do 0.15 times 40, and I get 6. If I wanted to just type in 15% of 40, I can do that too and still get 6. So no matter which way we do it, we get 6 students wearing Crocs. Let's look at this next one here. A bag of Skittles contains 60 pieces of candy. So that looks like our whole. In the whole bag, we have 60 pieces of candy. The table below shows the percentages of the different colors. So 10% are red, 30% are orange, yellow's 5%, green's 40%, and then purple's 15%. So part A says complete the table by determining how many Skittles there are of each color. So I'm going to first figure out how much there is for red. 10% is really easy. So we're going to do out the math and then I'm going to show you the trick for 10%. So for 10%, we just want 10% of 60. So I can do 10% times 60, right? Because it's the percent times the whole. Or if I need to change it to a decimal, it'd be 0.10 times 60. Or we can just type right on this Desmos calculator that I want 10% of 60. And it's going to tell us 6. Now maybe you already noticed that little pattern here for 10%. When you have 10%, you know how we have to move it, the decimal over once to change it from a percent to a decimal? We really just have to, or twice, we only have to move it over once for 10%. So it's kind of this weird thing because 10% is a tenth of it, and we use a base 10 system. That's how we're able to move decimals over to help us with these problems. Now, here's the thing. We can go through and multiply 30% times 60, 5% times 60, but we can actually use this 10% to help us figure out the rest. So before you just believe me, I want you to think about this if this was a proportional table. How would you get from 10 to 30? We would multiply by 3. So how are you going to get from 6 to this box? We're going to multiply by 3. 6 times 3 is 18. Let's see if that works. Let's type in our Desmos calculator. I want 30% of 60, and I want to see if we really do get 18. So we're going to type in 30% of 60, and we do get that 18. So what this is telling me is percents are proportional. So that means I can use the rules that I would do to fill in proportional tables to figure out some of these other percents. Like if I want to think about how do I go from 10 to 5, a lot of you might say divide by 2 or multiply by a half. So we can do the same thing here for 6. So 6 divided by 2 or times a half is just 3. If we check it on Desmos and we want to see 5% of 60, we do get 3. So this is going to work the whole way down. So 40%, I can use the 10 and multiply by 4, and the 6 and multiply by 4, or you can even add 10 and 30 is 40, 6 and 18 is 24. We can do that same strategy for the 15%. 10 plus 5 is 15, 6 plus 3 is 9. If we wanted to check it, if we add all these up, we should get 100%. And if we add all these up, we should also get 60 pieces of candy total. 100% should be 60 pieces of candy. Now part B says, is this table proportional? We kind of assumed it was to fill in the table, but if we wanted to check, we could do this unit rate the whole way. We could do 6 divided by 10, 18 divided by 30, 3 divided by 5, or if you'd rather do the decimal equivalent, so 6 divided by 0.10, 18 divided by 0.3, and you will get that we do get the same unit rate all the way across. So I'm going to leave that for you guys to do. Find out what that unit rate is. Show that it is proportional. But yes, it is proportional. So now we have exercise 3. So the Pepsi company is determining if they should make a new flavor of Mountain Dew. They survey 1,075 people and find that 473 like the new flavor. They're always making new Mountain Dews. They will produce the new flavor if over 40% of the people surveyed like it. So should they produce the new flavor of Mountain Dew? Justify your answer. So we can either figure out what 40% of 1,075 is, or we can figure out what percent 473 over 1,075 is. So 2 ways we can solve this problem. Both are correct. I want you to pause the video, pick one way, either figure out what 40% of 1,075 is, or figure out what percent of people liked the flavor. So pause the video, pick your way, and try it now. Okay, so if you did 40% of 1,075, let's just see what that looks like. So 40% of 1,075. I got 430. So that means more than 430 people had to have liked it. So this one is saying, yes, they should get the new flavor of Mountain Dew. But let's see if we can convert this 473 over 1,075 to a percent. So if you have the TI-34, you can just type in this fraction, hit the second button, the percent button, and then enter. But I don't have that on my computer to show you. So we're just going to type in 473 divided by, or as a fraction with, 1,075. I got 0.44. So that's as a decimal. And if I want to change a decimal to a percentage, I have to move this decimal point over 2 places. That's 44%. So this is saying 430 people liked it or 44% liked it. Either way, it's going to meet and go over that 40% rule. So should they produce the new flavor of Mountain Dew? So based on what we got, yes. That is our claim. They should make the new flavor. So our evidence, we have 44% of the people surveyed liked it. Or we could say they only needed 430 people to like it to get to that 40% goal. You could say whatever you want there, whatever your evidence was. And then our reasoning is kind of going back to our work and saying, yeah, well, 44% is above that 40% goal. And that just kind of wraps it all together. That was a CER. We did a claim, evidence, and reasoning. Anytime we have something like this where it says justify your answer in math, anytime we're giving any explanation, we should do a CER. So we have 3 practice problems. These ones are just finding the percentage of a number. If you have this Desmos calculator up, it will go very quickly. Or you can use rules like we kind of use the proportional rules here with the Skittles problem. Then you just have 2 questions. You have the percents and the total on both of them. You got to figure out what that part is. And then you have an exit ticket that's going to be very similar to this exercise 3. We got to see if I can buy Bender new toys, if he's playing with enough of them or not. So that's it for this lesson. When you're done with this lesson, make sure you're going on to Delta Math. You have your Delta Math practice too.